Anand sir, can you hear me, Anand sir? Dr. J. Anand sir? Dr. J. Anand sir, can you hear me, sir?
Hello.
J. Anand sir? Dr. J. Anand sir, can you hear me, sir?
Hello.
Dr. J. Anand sir? Anand sir, can you hear me, sir?
Hello, sir.
Anand sir?
What only, sir?
Dr. J. Anand sir?
Yak only audio. Exactly. No.
Anand sir? Dr. J. Anand sir? Anand sir? Dr. J. Anand sir? Am I audible, sir?
Hello.
Sir, can you hear me? Sir, can you hear me, sir? Anand sir? Anand sir?
Yes, sir. Yes, sir.
Yeah, can you hear me, sir?
Yeah. I disconnected my Bluetooth
Okay, sir.
device.
Can we start now?
Yes, sir. Please.
Okay, sir. Good afternoon to everybody, to all the dignitaries, faculty members, and dear participants. I welcome you all to the session, and I welcome our guest, Dr. J. Anand sir. So it is my great pleasure to extend a warm and cordial welcome to everyone present here today. So I also feel privileged to welcome our distinguished resource person, Dr. J. Anand sir. So
Yeah,
Dr. J. Anand sir, he is
yes,
currently
sir.
serving as a professor of marine engineering at Ahmed deemed to be University, Chennai. In addition to his academic responsibilities, he also serves as a director, IPR, and coordinator for NBA and NAC rankings and accreditation activities, contributing significantly to institutional development and quality enhancement. So, Anand sir, Dr. J. Anand sir completed his bachelor's degree in mechanical engineering, followed by his master's degree in thermal plant engineering, and later obtained his PhD in mechanical engineering with specialization in solar thermal energy. With more than 25 years of teaching and research experience, he also served as in several reputed institutions, including like Shastra deemed to be University, EGS Play Engineering College, Oxford Engineering College, and Rover College of Engineering and Technology, where he also held leadership positions such as principal. His research interests focus primarily on renewable energy systems, solar thermal systems, alternate fuels for internal combustion engines, solar photovoltaic systems, gasification, and bioenergy applications. He also contributed significantly to the advancement of sustainable energy technologies and engineering solutions for to face the challenges of environment. He also has an impressive profile with over 400 citations and a H index of 5, with publications in several high-impact international journals. His scholarly contributions include more than a dozen of international journal publications, conference papers, book chapters, and several textbooks, covering several subjects such as engineering thermodynamics, renewable energy sources, engineering mechanics, robotics, and artificial intelligence. In addition to his academic publications, he also made notable contributions to innovation and intellectual property with several industrial designs and patents related to renewable energy devices, alternate fuel systems, gasification technologies, and manufacturing systems. Some of his innovations include rooftop wind turbines, gasifier systems, solar collectors, and advanced manufacturing fixtures. He also contributed in global research collaborations through international conferences, book chapters, and development technology development initiatives aimed at sustainable energy and circular economy practices. So we are truly honored to welcome an accomplished academician, researcher, and innovator, Dr. J. Anand sir. His vast experience and expertise in renewable energy technologies and sustainable energy systems will, will surely provide us valuable insights and inspiration to all the participants present here. On behalf of the organizing team, I extend a heartfelt welcome to Dr. J. Anand sir and sincerely thank him for accepting our invitation and sharing his valuable time and expertise with us. We look forward to an enlightening and enriching session. Thank you.
Thank you, Ram sir.
Thank you, sir.
Thank you very much for
Yes,
the
sir.
great introduction, sir. Am I audible, sir?
You are audible, sir.
Yeah. Thank you very much for your nice introduction. So, due to the time constraint, I straight away go to the presentation. So, if there is any problem in hearing my voice or something, immediately you can raise your hands so that I can correct myself. So, the topic given to me is AML integrated solar PV power generation. The solar photovoltaic technology is a major energy conversion technology adopted very well. So, India is a country which is blessed with abundant quantity of solar energy, and we approximately have more than 300 bright sunny days per year, and the average solar radiation ranging from 4 to 7 kilowatt per meter square per day and it counts around 1600 to 2500 kilowatts hour per meter square per year. And based on the raw calculation, the estimated solar potential in India is around 748 kilo gigawatts. And the wellness of any country, it is based on the per capita consumption and the average energy consumption, that is electrical energy or any form of energy consumption. As far as India is concerned, it is around 1400 kilowatt per year, which is far below the global average, which is around 3500 kilowatt hour per year. Now, in US it is approximately 13,000 kilowatt per hour. So compared to those countries, the average energy consumption is very less. So this is due to various reasons. One is the lack of infrastructure for generating the required amount of energy. India is leading the world in terms of population, but in terms of energy consumption per person, it is very less. So we have a lot of potential to trap the solar energy, and as of now, the total installed capacity for power generation in terms of all forms of energy is around 480 gigawatts of energy, and the generation is around 200 gigawatts, and peak power demand is around 250 gigawatts. So as far as the energy source share is concerned, the major share is from thermal sources like coal. It is coming around 70 to 75%, and next comes hydroelectric energy. It is around 47 gigawatts, and wind and solar, it is around 11 to 12%. So we have a lot of potential to trap the solar energy, and we have already started installing these solar power plants of various higher capacities all over India. And by 2030, the expected target is around 50 gigawatts. And the solar power generation is highly dependent on weather conditions. Based on the weather only, the power output from the solar photovoltaic plant uh, comes compared to other conventional sources of energy like coal, where we have the control over the output power. But in case of solar power generation, the output power is depending entirely on the weather conditions, how much amount of irradiation and how much amount of moisture is in the environment, and how much amount of bright sunny days we are having, and the wind sheet, etc. So many things are there which directly control the output power of the uh, plant. So this ultimately leads to the instability in the power output of the plant, and the variation in irradiance create instability in the power output, and there we need the support of this artificial intelligence and machine learning for improving the power output, prediction of this efficiency, and also the maintenance of the PV solar systems. So before going into the main theme, let me have an overview of solar PV systems. The major components of the solar PV plant include solar panels, that is PV modules, and then DC combiner box, that is usually we call that as a DC distribution box, and then we have a solar inverter and the AC distribution box, and then energy systems, which is uh, Yeah, sorry. The major components of solar power PV plant, it includes solar panels, that is PV modules, and then DC combiner box. Usually we call that DC distribution box, and then we have a solar inverter along with the AC distribution box, and then we have a energy storage system. Of course, we need to have a grid connection if it is a grid connected PV plant, and then finally we have the monitoring and control system where we need the support of AI and ML for monitoring and controlling the performance of the system. So let me have a small discussion over the various components before discussing in detail. So solar panels, generally we have silicon crystalline panels. So as of now, there are four kinds of panels are available in the market. One is monocrystalline panel, and another one is polycrystalline panel. And third one is thin film panel, and the last one is bifacial panels. So out of this, polycrystalline panels are mostly used, and these panels are having an efficiency of 15 to 18 percentage maximum, and they occupy more space as well as they cost very less. And thin film panels are flexible in nature, and you can paste it on any surface of any space, but the efficiency remains very poor. It is around 10 to 13 percentage only. And recently we had monocrystalline panels in the market, which are having 19 to 23 percentage of efficiency, and its cost is little bit on the higher side, but the performance is comparatively good, and they also occupy very less space compared to other poly and thin film. And the latest technology comes through this bifacial panels, where you can have generation of electrical energy on the both sides of the panel, that is top side as well as bottom sides. Because you see, the PV energy is the conversion of solar light energy into electrical energy. Most people are thinking that the solar thermal energy is converted into electrical energy, but that is not true. The solar light energy is converted into electrical energy. So out of all these panels, PV panels, bifacial will give you the maximum possible efficiency, that is around 24%. So this is regarding the solar panels. And next one is DC combiner box, that is DC DB, shortly it is denoted. So DC distribution box. So the function of this DC distribution box is to collect the supply from all the PV panels, and it will combine the voltage and current supplied by all the PV panels, and it will be supplied to the solar inverter. Solar inverter function is to convert DC current into AC current, because the output of the solar panel, it is DC current, not AC current, it is DC current. So that DC current has to be converted into AC current before it is being supplied to load or grid. So we have a device for distributing the AC current from the solar inverter to the load or grid, which is known as AC distribution box. And next one is energy storage system. It is optional one. If you have a off-grid system, then you can have a battery for storing the energy produced, and you can use it for to run the load at any time, even in the night where there is no generation of electricity. And if you connect your plant to the on-grid, then there is no need of the energy storage. Straight away, whatever the energy produced from the plant, it can be supplied to the grid. So that is grid connected system. So that grid connection, it is usually maintained by the corresponding electricity board. And then finally we have the monitoring and control system. So monitoring and control system is very much important for smaller capacity plants. This is of least important. So this monitoring and control is done by manually. And for larger plant, in terms of gigawatt of capacity, this monitoring and control need lot of care, because any flaw in monitoring and control will lead to the complete shutdown of the plant. So this is the representation of whatever we had in the last slide in terms of images, graphical representation. So this is the solar PV array which receives the solar radiation, and it converts that solar radiation into DC power, and whatever the DC current produced by the individual panel, it is combined here in the DC combiner box, that is known as DC DB, and that current, DC current, is sent to a solar inverter in which the conversion of DC to AC taking place. Finally, it is given to a transformer where it steps up, and that is, it has to be, the voltage of the solar inverter has to match the grid voltage. So for that purpose, this transformer is used, and then this is the monitoring and the SCADA system, and then from this it is supplied to the grid. So there are so many challenges in solar PV system which include so many things. First one is intermittent solar radiation. So the solar radiation, it is not constant throughout the day. So the solar radiation is maximum during a particular time interval, that is between 12 p.m. to 2 p.m. and in the morning you have a minimum solar radiation, and then in the evening also you have minimum radiation, and of course during the night you don't have any solar radiation. So there are a lot of difference between irradiation and radiation. So radiation is nothing but it is the amount of energy released by the sun. So the amount of energy solar emitted from the sun, whereas irradiation is the amount of energy received in the earth's surface. So that is known as irradiance. That is the difference between radiation and irradiation. And then there is a partial shading. So the partial shading may be due to the movement of cloud, and then nearby structures, and then other, say if it is a overcast condition, means definitely there will be a shading problem. So which are all accounts for the reduction in the solar radiation. And definitely, of course, you can expect dust accumulation. So the presence of dust over the PV panels will definitely reduce the amount of solar radiation reaches the PV panel. And then the panel degradation, it is due to the various factors, primarily because of environmental effects, environmental conditions, corrosion, and then corrosion due to water, and then humidity present in the air, and then the temperature, etc. And then inefficient monitoring. So continuous monitoring is very much required in order to get maximum efficiency, maximum possible efficiency out of the plant. Already I told you about the panel efficiency, which is maximum for bifacial panel around 24%. And if you consider the overall plant efficiency, that is, if you should take into account that the efficiency, individual efficiency of panel, and then inverter, AC distribution box, wiring, connections, etc. Everything has to be taken into account. And if you take everything into account, the final efficiency of the plant may be around 20%. That is the overall efficiency. And then there are grid integration issues due to the load variation, frequency mismatching, etc. They are present, and this accounts for the grid integration issues. So these have challenges has to be taken into account for expecting maximum possible efficiency from the solar PV system. And these challenges finally reduce the energy output of the system. And this is the role of AI and machine learning in improving or enhancing the solar PV system efficiency or PV plant efficiency, where let us see where how they are going to help, how they are helping us in improving the efficiency. One is they are used for predicting the solar power output, and the next one is for optimizing the system efficiency and detecting faults automatically. So manual fault detection, it will take time and it is very difficult if it is a larger plant, and enabling predictive maintenance. So regular maintenance is required. So this AI and ML machine learning will definitely enable us to do the predictive maintenance or maintenance in advance. And finally, it is supporting us for doing the smart grid integration. So integration of this plant with the central grid is very important for on-grid solar PV systems. So this machine learning algorithms learn patterns from the large data sets of solar operations. So the data sets may be from sensors which are fixed at different components of the solar PV system, the data from the metallurgical department, the data load data from the grid, and then satellite images. So many data are processed, and these machine learning algorithms learn those patterns in order to determine these things which are listed above. And further, to have a clear idea about the integration of IA, ML, and DL in SPV solar photovoltaic generation, this slide is given. So artificial intelligence, it is a broad area of creating intelligence systems, and it is almost replica of human intelligence. And machine learning, it is a subset of the AI that learns from the data. So it is a subset. It is the extension of this artificial intelligence. So it improves automatically through experience. So a mathematical model will be developed, and based on the mathematical model, it will simulate, and based on the simulation data, it will assist us to maintain or control the operation of the SPV plant. And deep learning is the subset of machine learning. It is using neural networks. So this is capable of processing larger amount of data, which are complex, very complex in nature. So it may be, it will develop, predict data from linear relationships, and also non-linear relationships which are very complex in nature. So this is the AI architecture for solar PV systems, and you can have a idea about how the flow will be. So this is your solar panel, and you have sensor at a different location, at the different components or parts of the solar PV plant. So these solar panels receives radiation. So there will be a sensor fixed here on the top surface of the solar panel, which will give you the amount of solar radiation received, that is instantaneous solar radiation. So that data will be supplied. And similarly, the boost converter is there. So this boost converter is nothing but it's DC distribution box, and then solar inverter and AC distribution box. So this will give you, or this will also supply the data to the model. So data like input voltage, input current, and then output voltage, output current, the temperature of the DC distribution box, AC distribution box, and then is there any breakdown in the connection, wiring, etc. So many data are supplied. And finally, from here, it is electrical load is there, which is receiving current from the converter. And this one is the ML model. So solar panel application specifications and data collection, everything data may be cloud stored in the cloud, or it may be local storage, and then it is processed here in the ML model, and finally it predicts the duty. So decision is taken here, decision yes or no, or whether to change any parameter. So like that, the decision will be taken here by the machine learning model, and that decision will be given to the system again. So to consolidate solar sensors collect the PV data, not only sensor, from other reliable sources like the national meteorological data, satellite images. So everything will be feeded here, and all the data collected will be stored, and from the stored data it is processed by using AI and ML, and finally it gives signals to optimize the operation and the maintenance. So this will give you a idea about the various inputs given to the ML model. So we have solar PV data. So solar PV data means the amount of radiation received at the plant. So that is the radiation. And then numerical weather predictions. From weather stations you can receive this kind of data. So weather includes the temperature of air, velocity, wind velocity, and then humidity of the air, etc. So many things are there that you can get it from the weather station. And then we have satellite images. So image processing tools are there that will process the images, and it can predict the power output on a later date. Right? So you can see the movement of the clouds here in the satellite imaginary, and based on that you can decide the dates on which you are going to have a cloudy environment or overcast condition, or a bright sunny day or a rainy day. Like that you can predict, and based on that it will decide or predict the total amount of energy expected from a particular PV station. And topographical data is also available from the meteorological department, and that data also will be supplied to the ML model. So after processing all those data, the signals will be used for maintenance and control and predict the performance of the solar plant. So finally this ML model leads to improved solar PV generation and also forecasting. So these are the common artificial intelligence and machine learning techniques used for predicting the performance of the solar PV plants. So for the first one is artificial neural network, which are broader in nature, and then we have support vector mechanisms, and then we have random forest mechanisms, and then we have short-term memory, long short-term memory networks, and then finally we have reinforcement learning. So deep learning is the method which is used to predict the performance very accurately. So in the case of artificial neural networks, there's a machine learning technique where it learns patterns from the historical data. So the plant will be having this historical data of the amount of radiation received through the year per day and at a different time intervals between 8 to 9 a.m. in the morning and then 9 to 10 a.m. in the morning. Like that, it will be having historical data. And then the condition of environmental conditions like humidity, wind velocity, average wind velocity. So those data are utilized here for making the patterns uh, to estimate the output of the plant. So this is the use of artificial neural networks in the solar PV. And then we have support vector mechanisms. And this support vector mechanisms are supervised ML machine learning algorithms, and it is considered as highly accurate in handling non-linear data. So there are data known as linear data and non-linear data. For example, uh, the time versus the salary. For example, so if you work for 1 hour, your salary is 100 rupees. So in that case, if you work for 3 hours, your salary is going to be 300 rupees. So it is a linear. So when the time increases, automatically the salary also increases. So this is a linear data, and the ANN is helpful in handling linear data, whereas SVM is handling non-linear data. In some cases, experience may give you more salary, but in some other cases, the experience is going to be a barrier for getting very higher salaries. See, where you uh, need to provide your physical work. So in that case, people will be looking for young people because they are physically strong. So in that case, young people will get more salary, and then aged people, in fact, they will be having more experience. So in that case, it will become a non-linear. So in such cases, in order to develop relationships where you have a non-linear data, you can go for this support vector mechanisms. So it works by finding optimal boundary that separates data into different categories or predict values with the maximum accuracy. And one more example I can give you for non-linear data, that is the temperature and photovoltaic efficiency. We know that the photovoltaic, that is PV cell efficiency, it strongly depending on the amount of irradiation received. But the temperature of air, it is a non-linear. It is having a non-linear relationship. So it is complex relationship. Sometimes with the temperature, increase in temperature, the efficiency of the PV cell may increase, and some other time, based on the other parameters like humidity, wind velocity, even if the temperature increases, the PV cell efficiency come down. But in general, with the increase of temperature, the cell efficiency will come down. So normally we used to calculate the efficiency of all PV panels at a standard temperature of 25 degrees Celsius. So when the temperature is more than 25 degrees Celsius, definitely there will be a reduction of 0.8 percentage for every 1 degree rise in atmospheric or environmental temperature. And then next one is random forest algorithm. This is a ML algorithm, machine learning algorithm, that combines multiple decision trees to improve prediction accuracy and reduce overfitting. So overfitting problem can be reduced when you go for the random forest algorithm. Next one is convolutional neural networks, shortly known as CNN. This CNN is increasingly used in solar PV generation nowadays, and it is a deep learning model that use convolution operation to extract special features from data widely used for image analysis and the solar irradiation problems. Then next we have LSTM networks, long short term memory networks. So it is a special type of recurrent neural network designed to learn patterns from sequential or time series data. As far as this model is concerned, it is an advanced model in deep learning and is widely used in forecasting problems where past information influences future values. And finally, we have reinforced learning. So this reinforced learning model, it learns through trial and error. So it fixes on value and it will implement that value, and based on the output of plant, it will change the input value again until the maximum performance is obtained. So it is used for MPPT optimization, and later we will discuss what is meant by MPPT. And it is also used for determining the charging and discharging cycle of the energy storage, that is battery storage, and it is also used for fixing the solar angle, solar panel angle. So solar panel angle is very much important as far as the plant construction is concerned. It should be installed in such a way that the radiation, maximum radiation, is received normal to the surface of the PV panel. So as it depends upon the angle of the particular site, that is Earth, with the sun. So normally for India, the inclination angle of solar panels is in between 10 to 12 degrees, or even you can go for 10 to 14 degrees. And this is the AI framework for solar PV forecasting by using AI and ML model. And these are all the input data, weather data, satellite images, historical photovoltaic data, and then time and seasonals, because seasonal effects are very much important. In winter days, we have long daytime and short night time. And in case of summer period, we have in winter season short daytime and long night time, and in case of summer period, very long daytime and less night time. So like that, the time and also the reception of solar irradiation throughout the day, from morning 6 a.m. to evening 6 p.m. how much amount of radiation is received. So like that, the information regarding to time and season, summer season, winter season, and then the rainy season, etc. So these input data are processed here by using different models, ANN, CNN, LSTM, SVM, and the random forest models, and in order to forecast predicted solar power, and then for short term and long term outputs, and then for optimizing the grid. So solar power forecasting, it is important for grid stability, and the machine learning models, already in the last diagram we have discussed, it uses the inputs such as solar irradiation, and then temperature of air, and then humidity, wind speed, cloud cover. So temperature, already I told that we are using the standard temperature of 25 degrees Celsius for predicting the plant efficiency or panel efficiency. Humidity, it represents the amount of moisture present in the atmospheric air. It also indirectly or directly affects the performance of the plant. So during the summer period, the humidity value may be as high as 70% to 80%. So presence of water vapor, it will scatter the solar radiation. So that will increase the diffused radiation, and also the condensation of those moisture present in the air on the panel surfaces. It will definitely reduce the performance of the panel. And then wind speed, it is a factor which influences the power output of the plant. So when the wind speed is higher, automatically the panel will be cool. So the panel temperature is also a factor which decides the performance. So because of the lower panel temperature, the efficiency of the panel will also come down. And cloud cover, see, because the cloud is always traveling, so because of the cloud cover, you can expect uneven solar radiation on the panel surface, and that will create an imbalance of the power supply within the modules of the plant, and that leads to several operational challenges. So these are all the factors which require forecasting based on the historical data. And the next one is the important parameter, which is known as maximum power point tracking, that is MPPT. So MPPT, it is a controller which assists this solar panel for maximum conversion of solar radiation into electrical energy. So we have generally two kind of controllers for doing the same purpose, that is in order to maximize the conversion efficiency. So we have PWM panels, that is pulse modulation panels, that is controllers, and then another one is maximum power point tracking controllers. So these controllers ensure that solar panels operate at the maximum efficiency, though they assist the panels to extract maximum conversion. So there are two methods here used. One is perturb and observe, and another one is incremental conductions. So in case of perturb and observe method, the controller will slightly change the panel voltage and observe the power output. So slightly the panel voltage. Normally there are different panel voltages based on the design. So we have 12 volt panels, we have 24 volt panels, we have 32 volt panels, and we have 38 volt panels. So the power output of the panel, it is calculated from the voltage and current generated. So V and I determine the total power output of the panel. So in case of perturb and observe method, what the controller will do is it will slightly change the panel voltage and it will observe the power output. So if the power increases, what it will do is it will continue in changing the voltage in the same direction. So the changes, it may be increasing voltage or decreasing voltage. So based on the output of the panel, if the power output increases, then the MPPT controller will keep on changing in the particular direction, and it will wait for the maximum until maximum power is reached. So once the maximum MPPT is reached, and after that it will stop. So this is a simple method, perturb and observe method. In the case of incremental conduction algorithm, it uses the slope of PV power voltage curve to locate the exact maximum power point. So these are all the traditional methods which require very less investment. Simple MPPT device will have these two techniques. And nowadays AI-based MPPTs are used. And in this AI-based MPPT, neural networks, fuzzy logic, and deep learning techniques are in place. In case of ANN, it learns from the nonlinear relationship between environmental parameters and maximum power. And in case of fuzzy logic controls, it uses rule-based decision system instead of precise mathematical models. So it will not use precise mathematical models. And in case of deep learning systems, advanced neural networks are used for complex solar prediction and MPPT optimization. So deep learning already it is a subset of machine learning. Its benefits are faster response to weather changes, and it is having very high efficiency and reduced oscillation around maximum power point. So how AI can assist in fault detection in PV system? So there are different kinds of faults. One is hotspots. Hotspots occur in the PV system, especially in the PV panel, due to malfunction of individual modules of the uh, PV cell, because it is a polycrystalline or monocrystalline based crystals are there for power generation, which is typically a semiconductor device which converts the it utilizes the photovoltaic effect in order to generate electric energy from solar radiation, which contains photons. So when there is a malfunction in the PV modules, what will happen? There will be a hotspot, and this presence of these hotspots will definitely, if it is not identified properly, it will lead to the that is malfunction of the entire panel. And then cell cracks. This is also another problem inside the solar panel, that is modules, because of various environmental factors. So hotspots also ultimately leads to cell crack in the solar cell. And then there is an inverter failure. So inverter failures may be due to the inefficient air supply. So inverter is a device which converts a DC current into AC current. So when there is no ventilation, proper ventilation, it will be overheated, and finally it leads to inverter failure. And then wiring faults. So wiring is essential aspect as far as the PV plant is concerned, because it transmits energy from the PV plant to various components, to DC distribution box, and then inverters, and then AC inverter, AC distribution box, and then finally to the grid. So throughout this wiring is required, and if there is any loose connection, ultimately it will lead to spark, and that will damage the entire system. And then shading losses. This shading loss is due to the various factors. One is movement of the cloud, and then movement of that is nearby sections, and then other factors like trees and other things. So this shading losses also taken into account, and that is also considered as a fault as far as a PV system is concerned. So predictive maintenance as far as PV plant is concerned, how they are utilizing the machine learning to anticipate equipment failures are discussed in this slide. So for doing the predictive maintenance, that is maintenance in advance before failure, what are all the data required? One is voltage and current sensors, the data from voltage and current sensors, and then temperature data, temperature of the panel as well as temperature of the atmospheric air, and then historical performance records. So historical performance records means it is the performance of the individual components as well as the overall plant. And these are all the benefits of doing the predictive maintenance. One is reduced downtime. Downtime means it is the time in which the plant is in shutdown, right? When there is no output from the plant, then it is known as downtime, and then lower maintenance costs. So instead of replacing the entire component, instead of replacing the entire system, it is better to replace certain part or certain parts or components of the system. Definitely, it will reduce the overall maintenance cost, and that is possible only with the predictive maintenance. And then increase the system lifespan. Normally, for a solar PV plant, the guaranteed lifetime is around 20 to 25 years. As far as the panel is concerned, it is also around 20 to 25 years. That is operational lifespan of solar PV panel. But in case of overall plant is concerned, the lifespan is depending upon the lifespan of individual components. So when you do predictive maintenance, definitely you can increase the total system lifespan. And these are all the recent developments in the utilization of AIML for the operation of the solar plant using drones for the inspection, combined with artificial intelligence. So it is used for drones are used for capturing images of those plants, and based on the inspection of those images, you can determine the cracks in the panel, that is solar panel, and then hot spots, that is thermal imaging. By using thermal imaging technique, you can locate these hot spots in the panel, and then you can determine the amount of dust accumulation on the surface of the solar panel. So dust accumulation is a major problem when you have more wind speed. Definitely the amount of dust accumulated on the surface of the solar panel will increases, and this will ultimately reduce the radiation reaching the panel surface, and that will lead to the drop down in the efficiency of the entire system. So here the drone based inspection utilizes the computer vision algorithms to analyze thermal images and to identify defects very quickly. And by using AI, you can predict the solar irradiance also. So these ML models forecast solar irradiance using the weather data, satellite data, and sky images. So these data can be received from national data center, weather stations, and then other sources. And these machine learning techniques can predict solar irradiation hours in advance for improved grid management. So this meaning is the output of the solar plant is entirely depending upon the solar irradiation. So, but by the same time, the grid is specifically designed for a particular handling particular load, right? Just like that, you cannot produce any amount of solar power, and you cannot feed that generate power into the load. If you do that, what will happen is, ultimately, and the grid will be the failure of the grid will be there. So, in order to avoid these that is complexities, you need to have a proper mechanism. Based on that, only you can feed the generated power into the grid in order to keep the grid in working condition throughout the year without any fault. And that kind of integration is known as smart grid integration. So this enables efficient integration of solar PV into smart grids. So the key application of this smart grid integration is load forecasting. So we know that the load on the grid may not be constant throughout the day, right? It may be very high, maximum between morning 6 a.m. to 9 a.m. and after that it will be moderate, and once again it will keep on increasing. between evening 6 p.m. to 9 p.m. And then in the night it will be constant almost. So based on these data, the load forecasting can be done. And then energy storage management. So all the energy which are generated cannot be fed into the grid directly. Based on the requirement only you can feed, right? So the additional energy generated can be stored in the system within the site itself. So for managing those energy storage, this smart grid integration is required. So when there is excess energy, that excess energy can be stored in the battery system, and when there is a requirement, when the grid is overloaded, this excess energy which is stored in the battery can be supplied or can be fed into the grid. So for managing those charging and discharging of the battery system, we need to have a smart grid and demand response optimization. So that is between the storage and discharge of the supply. So this ultimately improves energy stability and grid integrity. So ultimately the AI helps optimize solar power plants through panel orientation optimization. So orientation, I have told you, should be oriented towards south and with a tilt angle of around 12 to 13 degrees. That is tilt angle adjustment. It also depends upon entirely the location of the site and selection of site. So the site selector should be free from any obstructions which prevents the fall of solar radiation, and then energy storage scheduling. So that is battery storage and discharge scheduling. So these techniques, when you follow these techniques, this definitely will increase the overall plant efficiency. And finally, we have digital twin for solar plants. It is a virtual model actually for the prediction of the actual plant. So the virtual model is created, and it is integrated with the AI and ML. So this virtual model is fed with the inputs which are received from the various sensors of the real SPV plant, and based on the SPV the data received from the sensors of the real plant, it will process and it can predict the instantaneous efficiency of a particular real model. So its function is real-time monitoring. So from a remote location, you can calculate or you can observe the performance of the plant. So you can simulate the performance and you can predict the fault, and finally you can optimize the operations in the plant. These are the benefits of AI in solar systems: increased energy output, and you can forecast the accurate energy output, and you can minimize the operational cost, and you can automate the fault detection for doing preventive maintenance, and there is an improved system reliability. And the limitations. First one is large data requirement. So when you use AI and ML, you need to feed variety of data which are huge in magnitude. So large data is required, and then the high computational cost. Sorry. And then the quality of data. Accurate data is required for predicting the accurate results, and of course there is a cybersecurity risk. And these are all the future trends in AI-based solar energy. One is autonomous solar power plants. So autonomous means without the aid of human. They can operate independently, and then AI integrated smart grids, and then digital twins for energy systems, and then AI-driven energy storage optimization. And these are all the plants, examples of the plants which are employing AI/ML for their optimization of power. We have Cochin International Airport Limited Solar Power Project, which is of 55 megawatt capacity, and AI is applied here for monitoring and performance analytics. And we have Tata Solar Power Plant, which is in Pavagada, Karnataka, of 300 megawatt, which is larger in capacity. And here AI is used for doing predictive maintenance. And we have renewable power solar farms in Kurnool, Andhra Pradesh, of 39 megawatt capacity. So for doing energy forecasting, the AI is useless. So these are all the examples of solar PV plants in which AI is and ML is integrated. And finally, we can conclude that this AI and machine learning are transforming solar PV systems for by improving its efficiency, enhancing its reliability, and enabling predictive maintenance and supporting smart grid integration. And these definite technologies will play a critical role in future renewable energy systems. So with this, the presentation is over. Now it is time for discussion.
Thank you, Professor.
Thank you, Mr.
Dear participants, do you have any now the question session? So do you have any questions or doubts? You just kindly ask to Professor Anand. Let me take any questions in the chat box. Dear participants, unmute yourself, and do you have any questions? Kindly ask to Professor Anand sir. Professor, shall we conclude? I think there is no questions from the participants. So shall we conclude the session, Professor?
Okay, Professor, thank you for inviting me for our presentation. I am also feel greatly honored to share my knowledge in the recent topic. Definitely, I hope this will be useful, very useful to the participants. Even if you have any queries which are need to be attended, you can share my communication details, and definitely I will be there to assist at any point of time. Thank you very much for inviting me for this session.
Thank you very much, sir, for the highly informative and insightful session. So your valuable presentation on distributed rooftop solar system, a comprehensive technical overview, has certainly provided a new perspective for all the participants. Once again, on behalf of management and the organizing team, Department of Mechanical Engineering, Dr. Welltech Multitech, Dr. Rangarajan, Dr. Saudula Engineering College, I extend my sincere thanks to Dr. J. Anand, Professor, Amit University, Chennai, so for sparing his valuable time with us today, sir. So thank you very much, sir. So with this, we come to the end of the day 5, session 10 of the FDP. We look forward to the active participation of all the attendees in the upcoming session last day. So thank you all for joining us. Thank you, participants. Thank you, Professor.
Thank you, sir. Thank you.
Dear participants, you may leave the session now. சார் ஸ்ட்ரீமிங் ஆஃப் பண்ணிருங்க சார்.